following equation is f of x equals plus or minus a, absolute value of x minus h plus k. The plus or minus determines whether the graph points up or down. A positive means it'll point up. A negative means it'll point down. A determines the slope of the graph. H determines the shift of the graph from left to right. If it's positive, it will shift left. If it's negative, it'll shift right. K determines the shift of the graph up and down. If it's positive, it will shift up. And if it's negative, it'll shift down. The vertex of the graph is at HK.
To move the graph from side to side requires a horizontal translation to be made. You can accomplish this by replacing the variable h with a positive or negative number. If a negative number is used, the graph moves to the right. On the other hand, if a positive number is used, the graph moves to the left. In order to do a vertical translation, the variable k must be altered. Replacing k with a negative number causes the graph to shift down. Conversely, a positive k will shift the graph up, as this example showed.
As I said before, the plus or minus determines the direction the graph points in. If you have the simple equation f of x is the absolute value of x, then it looks like this. It points up! Now, if we alter the equation by putting a negative in front of the absolute value of x, watch what happens. It flips the graph to point down. The value of y will now always be negative. Horizontal reflection flips over the y-axis. I didn't say anything about this before, since the graph would look exactly the same. But if you put a negative in front of the x, but inside the absolute value, the graph will do this. It'll flip over the y-axis. The graph will only look different if you have another value in the absolute value, with the x, you know. Say we take absolute value of x minus 5. First we move the graph right 5 units, then we put the negative in front of the x. It flips over the y-axis like this. The new equation is f of x equals absolute value of negative x minus 5.
A coefficient in front of the absolute value equation, represented by the a, changes the angle of the graph. For compression, the absolute value of the coefficient must be greater than 1. There is actually a coefficient in the original equation, but it is the ever elusive and rarely written 1. Here the coefficient 2 is used. As with other graphs, a greater value creates a skinnier graph. Thus, a smaller value creates a wider graph, otherwise known as a dilation. To do a dilation, one must replace the coefficient a with a value less than 1. In our example, we used a half. If a 0 is used, the graph is a horizontal line. If a negative value is used for the coefficient a vertical reflection is created.
If a negative number is used, the graph shifts to the right. On the other hand, if a negative number is used, the graph shifts to the left. That's wrong.
With a value less than 1. If our graph...